All right. This is one that hinges upon whether or not you were here when we did our little exploratory lesson on Desmos on this, right? And what we did on Desmos is um, we took simple equations and we started messing with them with sliders and seeing what happens, right? And I'm going to actually make a video of what that sort of looks like when we do that at some point, but we don't have it right now. So for our purposes, right, I'm just going to kind of give you a quick little rundown of what happens. So when we talk about transformations, what we're talking about are ways we can change a parent function, like a basic function, um, and what happens to it, and how we can recognize that um, based upon where the numbers are at, right? And so what we found, right, is that, and we're just going to start right at here, all right? What we found is that anytime you have a number that is multiplying by anything, pretty much, but multiplying at the beginning of it, where your x term is, right? This does two things, all right? So the first thing that the -2 does, right? The first thing we're going to look at is we're going to look at this, the negative sign. And what the negative sign does is the negative sign makes any absolute value or quadratic function, right? So the parent function for an absolute value is, like as shown, is this, right? And that's this function right here, right? That's the red function, all right? And then if you had a quadratic function, the parent function for that would be just this. So it would be just x squared, right? So when you multiply the front of that by something that's negative, what it does is it makes it so it opens down. So you see how this one is opening up, right? Because we're multiplying it by a negative, this tells you that it's opening down. So the very first thing we're going to describe is, it says describe 4 transformations that would need to happen to the graph of p of x to produce the graph of t of x. So you could say that you know, the graph will open down, right? Because of the negative sign in front, right? So that's the first one, right? The graph will open down because of the negative sign in front. Now, the next thing we want to do is we want to look at this number right here. So that number right here, if you look here, it always has a number, right? It's 1. So when it's 2, what happens is it takes this thing and it stretches it, right? It stretches it up. It makes it so that it opens, it kind of squeezes it, right? And so the language we used in class, and I think the other teachers are using this, is we will say the graph will be narrower. And if you look at our thing here, you can see this thing is definitely narrower than this, right? The graph will be narrower because of the 2 in front. All right. The next thing, all right, is you can see that on the parent function, and I got to kind of erase some of this stuff here. On the parent function, you will see that this thing, the parent functions are always at the point 0, 0, right? So this one is at 0, 0, this one's at 0, 0, right? Parent functions always go through the origin. Well, this thing isn't going through the origin, right? This thing starts right here at the point -3, -1. So look at this equation right here, and can you kind of see where this -3 sort of corresponds with this? And you go, oh yeah, that's right. That was my h, right? It was like x minus h, right? And then this right here, from those of you who remember what we did on Desmos, this responded to my K, right? And so those are two separate transformations that are going on that are required to move this from this to this, because if I just did this, it would still be here. So I have to move it to the left, and then I have to move it down one. So literally, all you gotta say is graph will, and then we're just gonna use the word translate, right? Translate just means move it. We'll translate 3 units to the left, and then the graph will also translate 1 unit down. Okay, and so if you're looking at this and you're saying, okay, how does that all look in one thing, right? And so if we have a graph, right, and if we take, so you should have all this, right? Let's erase this and let's make this free and clear here. So the very first thing I'm going to do, right, I'm just going through this. The graph will open down because of the negative sign. So that's going to mean that my new graph is going to look like this, right? Okay, so that's my new graph, right? I'm basically just going through this again. That's my new graph. So this is after step 1. Now it's going to be narrower because the 2 in front. So instead, right, and I'm going to go to green now, right, it's going to look like this. It's twice as steep, right? So here's what I got here, because it's twice as steep. All right, so that's what we get. And then the next transformation translates 3 units to the left. Well, if it goes 1, 2, 3, right, that's going to give me this, right? It's going to look like this, and then it's going to look like that, right? And then if I drop it down 1 unit, hopefully you should be able to see that that's when you get this right here, right? And it lines up right on that. So hope that is helping you guys out a little bit. But those are the transformations, right? And the you know, the proper, you know, math terms, you know, would be words like reflected, right? And so this first one, when it says it opens down, it's actually technically what's happening is we would just say it's reflecting over the x-axis, and it is reflecting over the x-axis. But basically, you're taking it and it's just kind of taking it and sort of turning it in space down that way, right? And then when it's narrowing, the word for that is stretching, right? We call it stretching that thing. All right. So I hope that you know, pretty much we're not super worried about whether the nomenclature, the language you're using, is exactly, you know, the proper math terms. Or just saying, can you recognize, looking at this, saying that, oh, okay, this thing right here means that this thing's flipping and it's going to be narrower. This means it's moving over 3 units to the left, and this means it's going down 1 unit. So, and you can see all that from that. That's what's really cool about things being written in a certain form. So that's what we're looking for. Those are the basic transformations. Good luck with that. And yeah, so that's the review. Hope this has been helpful, and good luck on the assessment on Tuesday.